Alright. We'll just turn it tomorrow. Okay. Just turn it in the same file. Alright. Today, polar coordinates all day, this is important, are going to be of the form r, comma, theta. You just graphed one in the DOM. That one would have been 4, comma, 270. And you graphed it exactly right. Now you wouldn't need the first point, but I didn't know how to say origin in your DOM. If here's the unit circle, so 4, 270, bam, right there. That's all polar coordinates are. Now you're going to have them in radians and degrees. What is the radian equivalent to 270? 3 pi over 2. So I could have written that exact same coordinate as 4, comma, 3 pi over 2. And that's a large portion of what we're doing today. We're just going to graph these and see if we can pinpoint where they would be. First slide. Number 1. 3, comma, 225. Somebody raise your hand and tell me what point you think 3, comma, 225 will be. Brayton. You're right. Out 3 units, 225 degrees. It is point C. You are correct. Joseph, what do you think about number 5? Number 5? Oh, okay. And you're right. 3 pi is here, and it would be B. Excellent. Caitlin, what about number 7? I will not hold on. You sound pretty confident. Not quite, but I like your confidence. Ooh, love all the people stating their opinions. Tyler Hale, what do you think it is? Thank you, Tyler Hale. You missed the boat. Tyler, what do you think it is? We're on number 7. What? I didn't see a yeah point. So see, come out 3. Now, positive 135 is here. Exactly. Negative 135 will be directly opposite the x-axis. That's probably the easiest way to do it. A negative angle, you just go to the positive angle and flip over the x-axis. So it would be C as well. Now, negative radius is more complicated. And I'm going to tell you this right now. Do the negative radii last. Do the negative radiuses last. What does that mean? It means, let's jump down here to number 9. This is a good example. Start with a positive radius. So you go out 3. Then go to negative 3 pi over 4. Well, 3 pi over 4 is here, so negative 3 pi over 4 is going to be here. The last thing you do is apply the negative to your radius. A negative radius flips you over the origin directly from where you are. So this one would be A. It is indeed. Yes. Yes, that you flip over the origin. Dylan, what point do you think number 3 is going to be? You can use your unit circle if you need it. In fact, you're going to need the unit circle all day. When in doubt, don't trust Brayton. Just kidding. Okay. Well, that is wrong. I wasn't kidding about that. But what do you think it is? What do you think it is? Mr. I know everything that it's not. Yeah. Josh, come on. Brayden, what do you got? You are wasting my... Very good. All right. You come out 3 units. 5 pi over 4 is here in your unit circle. Negative radius flips you over the origin, and it is also A. Very good. Questions about how we're graphing these? Good, because we're moving on. Next slide. Now they just ask you to plot them yourself. They gave you coordinates. They say graph them. Here's how I would do it on your homework. Here's how I would do it on your homework. I would just draw one graph. Well, you can just see how I do it. It's going to be hard for you all to tell me exactly where these are, so I'm just going to ask you what quadrant I should be plotting these in. Tyler Atkins, what quadrant is number 11 in? It would be. Quadrant 1, you're right. You come over 2 units, and then you rotate 45 degrees. Now, please note, your point will not be directly over the 2. It's rotating like a circle. So it's rotating, and it's actually going to be here with a radius of 2 and an angle of 45 degrees. So here's how I want you to do these later. Just draw one coordinate plane and then put, here is number 11. That's the point for number 11. You can just ballpark it. It's going to be at 2, but it's going to rotate, which is going to kind of move it. Yeah. Does that make sense, Caitlin? About why it's not? I think about it like this. You start here, right? Radius of 2. And let's call this mile marker 2. But as you rotate, you're now no longer directly above this because it's rotated. That's why it's not. It doesn't have to be perfect. I don't know how you would make it perfect. All right. Michelle, where's number 13 going to be located? I appreciate your honesty. Ferd, where's number 13 going to be? Up or down? You're right. 3, 90. You come out 3, rotate 90, and here's number 13. Number 15. Madden 95. Go. That's a really good year, Madden, by the way. 15. It would. You come out 3 units. 4 pi thirds is in this quadrant, so it's going to be approximately here. Radius of 3. This is number 15. Mr. Williamson, number 17. Where am I going to be? Which way? You're right. That's a tricky one. You come out 1. You go to pi, but then the negative radius is going to flip you over the origin. Tyler Atkins, do you have a question? Oh, it might be. I kind of just... Yeah, you're right. That would be 7 pi 6. There'd be more down here. You're correct. Roads, really? Don't take this the wrong way, but I don't care about pleasing you that much. Okay. I didn't mean that as mean as it sounded. That was I'm sorry. Dang it. Okay. I'll tell you what'll make you feel better. Why don't you tell me where number 19 is? Mr. Whatever. No, I'm just kidding. Where's number 19, Adam? Adam's going to tell us. Oh, it was right here. Positive 1, positive pi, but then the negative 1 flips it over the origin. Back to here. Positive 1, pi is here, and then negative 1 flips it over the origin. All right, one more time. On the y-axis? Let's see. Positive 2, positive pi over 2 is up here. Negative pi over 2 flips you over the x-axis. And then the negative radius flips you right back up, and you're exactly right. It'll be right here. Number 19. Muchos Garcias, sir. Oh, no. You could have several in the same spot. There's infinitely many ways to draw every polar coordinate. Think about this. This point, what is this? Negative 1 pi. This could have also been 1 comma 0, or 1 comma 2 pi, or 1 comma 4 pi. Or it could have been negative 1, 3 pi, negative 1 pi. There's infinitely many ways because every angle has infinitely many coterminal angles. In fact, the next 2 slides deal nothing more than, here's a point, give me 3 more representations of that exact same point. So yeah, you could have all of them on the same spot, just by happenstance. Questions about anything from this slide? I hope I did not hurt your feelings. I guess I didn't. Okay, now one thing you're going to see later that some people, because you're going to get this habit of negative. I'm flipping somewhere. Where is negative pi? Of what? Hold on. Where's positive pi? Negative pi is there also. Because positive pi is 180 degrees in this direction, negative pi is 180 degrees in that direction. That's the only one, pi or 180, whichever representation you get. That is the only thing that making it negative won't change it in polar coordinates at all. Because it's already on that axis. Okay. The next ones. Now, last class, this was the hardest part of the day. So, let's buckle down. All they say is, here are 3 polar coordinates. Boom, boom, boom. We want you to give us 3 more representations of them. Now, this one says, I want a positive radius. Let's just do 21. Well, our radius is already positive, so we don't have to do anything to it. So 5 is going to be our radius. Part A. It'll be 5, comma. But notice, it wants theta to be between 2 pi and 4 pi, which basically means we need to make one more revolution. How do you add a revolution to an angle? Add 2 pi. What is 2 pi in terms of 6? Very good. So you just add 12 pi over 6, 12 pi over 6, and what is that? Awesome. You got it. That's part A. That's part A. Actually, we're going to skip part B for a second because part C is pretty much the exact same thing. It wants a positive radius, which we already have, but it wants an angle between 0 and negative 2 pi. So you just have to subtract 1 revolution. So what's pi over 6 minus 12 pi 6? Negative 11 pi over 6. Very good. That is all you have to do on part A and C for all 3 of these. Keep the radius, because they're already all positive. Add 2 pi for A, subtract 2 pi for C. Part B is a tad more complicated. It wants a negative radius, so you know it's going to be negative 5. Let me tell you this. A negative radius does what on the unit circle? Flips over the origin. That's right. What's directly opposite of pi over 6? No, I mean on the unit circle. What's directly opposite? I like it. 7 pi over 6. So that's all you have to do for that one. Wow, I wish my first 6 up here wasn't so big. 7 pi over 6. You just make the radius negative and find what's directly opposite of your angle. And that's all you have to do on this thing. Wow, this class handled those much better than previous. Good, 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 good. Try 23 on your own. And I'll call on random people to see if you've got it. Try 23. I need A, B, and C. Who thinks they have part A for me? I'll call on somebody. Mr. Bursey, what do you think part A is? You got it. Would anybody, before we move on, like to ask where he got that? Okay. All he did was add 1 revolution, or 2 pi, to his original. What is 2 pi in terms of fourths? 8 over 4. So he took 3 pi over 4, added 2 pi, which is 8 pi over 4, because you have to have a common denominator, which is 11 pi over 4. Part C, Emily Rebel, you got it for me? Okay, I'll let you finish B and I'll come back to you. Crystal, you have C? Nice. Same exact thing, except instead of adding 8 pi over 4, we subtracted it. Mental high five. Emily, you got B? Almost? I'll go ahead and fill in the easy part. All I need from the exam. What? Instead of adding 2 pi, we subtracted 2 pi. No problem. It's all right. You mean to ask you the easier way to ask this question? What angle is directly opposite of this? Yeah, that's another way to do it. Just add pi. You got it. 7 pi. Yeah, don't forget to revert back to your original. You're good. Any questions about A, B, or C on 23? Where did that come from? She went to 3 pi over 4. Now, one way to do it, Joseph noticed, going directly opposite is really nothing more than adding pi, and you're welcome to do that. Or just look at your unit circle. What's directly opposite of 3 pi over 4 in the unit circle? There you go. That's where it came from. Questions about anything on this slide? Yes, sir. Oh, you didn't have your hand up? That's in the problem. All right. Yeah, it's right here. I didn't erase it. All right, any questions on that? Great, that was the longest slide last block. All right, 27 and 29. These simply say, here's a point, which, maybe all, how many of these points or which ones are the same? Easiest way to do this is just to graph them. 7, wow, that's really bad. Let me just get to, here will be my axes. So, number 27. 7 and 140. 7, 140 is approximately here. Here is my original. So now I just need to see which of these are the same. So part A, I'm going to go positive 7, 320, but then negative radius flips it over. Is that the same? Yes. So A. Now I go to B. Positive 7, 40 degrees, negative 40 flips you over the x-axis. Negative radius flips you over the origin. Is that the same? Yep. So far so good. C. Positive 7, 220 degrees. Radius is negative, so it takes me over here. Not the same, so I'm just going to leave that one off. D. Positive 7, positive 220. Negative 220 flips you over the x-axis, which takes you here. So yes. Don't forget, negative angle, negative theta flips you over the x-axis, unless you're on it, and the radius flips you over the origin. So that one would be A, B, and D. Take a minute to look at 29, and we'll just go around the room and I'll ask people if A, B, C, and D are. Well, it's all about just if you have a unit circle. Really, here's the radius is pretty irrelevant in these. Only thing you need to know about the radius is it positive, is it negative, because they're all 7 on that one. And similarly, they're all 2 on number 29. So really all you have to know is where is your angle and then what flipping are you doing. Yeah. Yep. Yeah. The original? Oh, I don't know. Let's see. 3 pi over 4 is here? No, because negative 3 pi over 4 will put you down here. Does that make sense? Okay. I'm sorry. So it could be. Meredith, what do you think about part A? Yay or nay? Ooh, I'm hearing conflicting results. Let's see. 7 pi over 4 is here, and the angle is negative, which takes you up here. So actually it would be no. But had it been a negative radius as well, that would have flipped us down here. In fact, that kind of jumps the gun. A is not, but which one is? Well, I meant by what I just said. I said if the radius was negative, it would have taken us down here. Which one is the same but with a negative radius? D. So let's go ahead and throw that one on there. All right. B. Brayton, what do you think? 2 positive 5 pi over 4. Yes, that one is. So B. And let's see. Dylan Roberts, what about C? Tricky. 2 negatives. Let's see. Positive pi over 4 is in which quadrant? Correct. The negative angle is going to flip you over the x-axis and take you down here. And then the negative radius is actually going to flip you over here. So, not quite. So it would just be B and D. You want to do another one? Okay. Alright. Sorry, actually it'll be hard to make one of these up. Let's just do one straight. Maybe four. Ooh, but that would. Hold on, you just want to do one more? Like one from your homework, number 28? Okay. So, Caitlin, what quadrant is number 28's original in? Quadrant 2, you're right. 4, 120 puts us right about here, right? Alright. So, now we just go through them each one at a time and see which one also ends up here. So, part A, positive 4, you always start with positive. 300 degrees is here, okay? Negative radius flips you over the origin. So that one would be. So, A. Now, you look at B and tell me if you think it is or isn't. That's right. Do positive, positive, then do your angle, then do your radius. Where's 240? Which quadrant? You're right. You were here. The negative angle took you here. But then the negative radius took you out of here back down here. So it's not B. Try C. We're going to get this. Go ahead. What's she thinking? Go ahead. Over the origin. Over the x-axis. Vertically. C is yes. It's alright. Where's 240? You're right. But it's negative, so you flip it over the x-axis. Yes. It always flips vertically. Alright. D's the lucky one. We're going to get this one. Fourth time's a charm. What is D? Really? Really? That's correct. If your angle is too big, just subtract either 2 pi or in this case 360. 480 minus 360 is 120, and that's actually just the exact same as that now. Questions about that slide? You're welcome. All right. Yes. No. All I want you to do is just say yes or no. I mean, you might need to, but it's up to you. All right. You need to write down the highlighted portion, and I'll explain it in just a second. All you need to write down is the highlighted portion, and I'll explain what that is in just a second. There is, but I don't think it's as hard as the first two parts. It just has a formula, what you're writing down right now. These formulas are going to help you. It's going to give you a polar coordinate and say, what is the rectangular coordinate that you guys are used to, like x comma y. So you're going to convert the polar coordinate into rectangular coordinates with the use of these formulas. Because anytime you graph one of these points, r theta, right? R theta, here's the classic example. See how every time there's a right triangle formed with the adjacent part of your angle being your x, and the, just like on the unit circle, and the opposite part will always be your y. So they were saying, well, cosine of theta is just x over r, and if you solve for x, it's r cosine theta. And if you solve for y, sine of theta is y over r. So if you solve for y, so all that said, here's basically what it boils down to. If I give you a rectangular coordinate, like, a polar coordinate, like -2, I don't know, pi over 6. All you have to do to find your rectangular coordinate is plug those two things, r and theta, into these formulas. X is going to be -2 cosine pi over 6. Plug that in, whatever gives you your x. Y is going to be -2 times sine pi over 6. Boom, that's all you have to do. And that's the whole point of all of this. You just plug your r and your theta into that formula, and you have your rectangular coordinates. Just make sure you're in the correct mode. You're going to have to be bouncing back and forth between radian and degree mode. That one would be radian. Questions about that? All right. Well, I don't know. I didn't plug them in. Sounds like about 2. About 2. You can round these because your calculator is going to give you a pretty horrible decimal. What are you getting for these, Emily? That's correct. And yep, just use sine instead of cosine. -1 even. There you go. And you found your rectangular coordinates. This whole slide is done just like that. Only difference is you have to bounce back and forth between radians and degrees. Only difference. R cosine theta, R sine theta. 39, please notice. In fact, we'll do 39. That's a radian. So there's no degree. Just because there's no pi, it's still a radian. So, for 39, 7.4 cosine 2.5. And what's that going to give me for x? Very good. And what would my y value be? Rocking and a rolling. Moving and I'm sorry. Questions about where those are coming from? Fantastic. The only other slide we have now, guess what? If we're starting with polar and going to rectangular, guess what your next slide is going to be? You're right. You're going to start with rectangular and go to polar. And now they're just this simple. Please notice, even if you didn't know the radius, but if you knew the rectangular coordinates, working backwards, if your coordinates are x and y, and you're looking for r, guess how we're going to solve for r? Pythagorean theorem. X squared plus y squared equals r squared to find your radius. Every time. If your point is 7, -4, 7 squared plus -4 squared equals r squared. Find r. Bam, that's how you do it. To find your degree, find your degree. It'll always set up like this. Tangent of your angle that you're looking for is going to be y over x. Let me give you an example. Let's say we have the point -3, -2. Okay? It's always going to work out, no matter where you graph it, to where your angle is going to set up as tangent of theta equals your y over your x. Every time. Now, last class I was mean, and I wanted them to give me an angle between 0 and 360 or 0 and 2 pi. Somebody punch that in the calculator and tell me what you get. Now, how do you solve for theta? Yeah, tan inverse. And I don't care what mode you're in. Be in degree mode. Degrees are just easier to visualize. Tan inverse of 2/3. 33.6. Now, listen. You're going to have to use logic. What quadrant is -3, -2 in? This is important. I had to answer this one question more than any other question last class, so please pay attention. That's in the third quadrant. If you were to plot that, which I would recommend doing for visualization, -3, -2 is here, right? What did it say, 33 degrees? 33 is this angle right here. And it's always going to give you that. It's always going to give you the reference angle. Sometimes it might say -33, whatever. You just plus that right here. Just keep positive of it. You're going to have to use logic. Because when the thetas here don't start here, where do they start? Over here. So if this is 33, what would my actual theta be? 213. But it's not always going to be 180 plus your angle. It depends on what quadrant you're in. If you want, I can give you a little chart for that. Well, do you get how we got 33? But all angles start here, right? So it went what? It went 180 plus that last little 33 piece that you found. But see, it's not always going to be 180 plus that. So I'm going to give you a little cheat sheet. If your point is in the first quadrant, then whatever your calculator gives you is the answer. It's just going to tell you 40 degrees, 60 degrees, and that's right. If it's in the first quadrant, it's just theta. If it's your angle. If it's in the second quadrant, you're going to find it as 180 minus theta. So let's say it gives you a point in the second quadrant. You do tan inverse of y over x, which is perfect, and it's going to say 60. Well, what is your actual angle? 180 minus that. So it'll be 120. Because that would be giving you this. But what would you be interested in? This portion. 180 minus that. Third quadrant. Like the one we just did. What did we do? Add 180? That's what we're doing. 180 plus theta. And the fourth quadrant will be 360 minus theta. So that's the way, and always take the positive of theta. Your calculator is going to try to help you sometimes and help you skip a step. Don't let it. Like for instance, if he gives you a point and you do tan inverse of y over x, and it's going to say negative 60, just do positive 60 every time. So, find the formula you'd be using and do 180 plus or whatever formula you're using with a positive 60. Only use the positive of what it gives you. And that way you can just use those formulas. Let's look at one. Somebody pick what looks to be the hardest one on that page. What? 43. Alright, to find the radius, you just do x squared plus r squared. X squared plus y squared equals r squared. What's 2 squared? Now, if your calculator is a order of operations Nazi, so please do not punch in negative 2 radical 3 squared because it's going to give you a negative number. Just think about it. 2 squared is 4. What's the square root of 3 squared? 3. So, what's 4 times 3? There you go. That's this squared is 4 times 3. So 16 equals r squared. What's r? 4. That part's done. To find your angle, first off, what quadrant are we in? We'll just try to grab it. Positive x, negative y. Is that fourth quadrant? That's really all you need. It doesn't matter how accurate your point is. Just you need to know what quadrant you're in so you know which formula I gave you. Positive x, negative y. So, tan inverse, and they're all going to set up like this, of your y over your x. Every time, that's how they're going to go. Tan inverse of your y over x. Crystal, what's your calculator telling you? Are you in degree mode? Let's see what she gets to. Are you sure you're in degree mode? Negative 60? I'll get your calculator in just a second. Who else is getting negative 60? Okay, good. So we're going to go with that for just a second. Now remember, use the positive. Let me just do it on my calculator. How about that? That'd probably just be easier. Yeah. You know what's really sad is the only reason I didn't do this earlier is because I wanted to take the time to get out my virtual calculator. That's laziness, people. Don't let it bite you. Okay, so tan inverse. Oh, make sure you're in degree mode, which I am not. Of negative 2 radical 3. Oh, darn it. Negative 2 radical 3. Now, this is tricky because your order of operations, you're going to have to close. You're going to need 2 parentheses here because it's a fraction. Your numerator divided by your denominator. Enter. Negative 60. Now, what quadrant were we in? Fourth. What was the formula I gave you for the fourth? Yeah. So 360 minus 60, 300 is your angle. Yeah, just drop the negative. Question. All right. Take this off the board. Shazam. There you go.